extra set of fingers or toes, not hands, but fingers or toes. And if we're looking at multifactorial genes, so we're looking at, not to say that this young child has multifactorial genes necessarily, but there are more than a few ways to, let's say, achieve this particular child's hair color. We can manipulate that environment, and like if I wanted blonde hair tomorrow, I could go and bleach my hair, for example. Of course, it could also be passed on by mother and father. As far as skin complexion goes, that's more of a mother and father, traditionally mother and father passing of that particular trait. But then there's also components where sometimes the skin colors could be manipulated as well. And we could do this hormonally with manipulating the melanin in our body. So these could be multifactorial, meaning a lot of different components could go into changing these particular items or creating this condition. Not that it's negative or positive, but again, just creating those outcomes. As far as genes and disease risk, mostly this would be the environmental effects on genes and the idea of something called genetic determinism. So this could be, depending on the environment, helpful or harmful. It really does depend on circumstances. Could you guys think of environmental effects on genes that might take place that could be more helpful, if anything? Things that might change?
What do you mean to be helpful?
Helpful would be like, due to these particular gene changes, it's keeping the patient free of, maybe not free of, but greatly decreasing harm based on environmental factors.
Like maybe close by to a power plant or something like that?
Yeah.
Or more.
Next. But close to a power plant, would that be helpful or harmful?
That's hurtful.
Yeah, harmful.
Yeah, harmful. Okay.
I can't think of anything that would promote something that would help your body.
Like sparkling melanin to help with UV rays.
Yeah.
That's
That's a good example of a helpful.
smart.
Especially in think of environmental factors, sin beaten down. The more melanin you have, the more you can have resistance against some of the UV destruction that can occur. So it's actually helpful to have darker complexion. Yeah, good. All right, cells. One of the things I want to note about the cell is that we have millions, trillions of these cells. And these cells are constantly trying to divide. That's the only way we can get anywhere with cell division. With cell division, even before it takes place, we have to undergo something called the cell cycle. And the cell cycle really is a kind of a precursor to the conversation we'll have later on related to cancer. So I'm going to annotate for you here. So we have a cell, and I'll kind of go over briefly what the cell cycle means. Before we divide, before our cells divide, they want to make sure that they're dividing in the best form of themselves. They want to divide in a healthy form. So prior to doing that, it goes through a number of kind of checks and balances of sorts. So there's a starting point. We can say the starting point is drawn up by something that promotes, again, the cycle of checks, not the division component quite yet. It's going to start the first cycle of checks. Something called proto-oncogene really starts the cell cycle. The cell cycle takes a pause every now and then by something called, I'm going to put it differently. The cell cycle takes a little pause by something called, we had proto-oncogenes to start, now we have tumor suppressor
Papi?
to stop the cell
Oh
cycle.
no.
It stops to check for mutations
Use a
checks to
different
see if the
size or
cell needs
something?
any repair or if there's any cell damage present. And it uses that time, if it is identified
It's because
that
of
there's
the
a mutation
pandemic.
or
What are we gonna do?
kind of, maybe cell structure damage, takes time to repair these issues.
Last time I checked, I was 285 pounds.
Tumor suppressor gene.
I was just short of.
We'll talk about this all
You'll
again
be fine.
in
You'll
greater
lose it again.
detail as we get to the
You'll
cancer
lose it again.
section in a couple of weeks.
I mean, I just ate 3 donuts
Once
today.
the tumor suppressor gene
And some
is
pizza.
done with its checks, it fixes mutations.
So there's that.
Or any cell repairs. It does this also with the help of something called caretaker genes. So these kind of work together to repair issues. Once all of that is checked off and it gets the green light to continue to proceed to the cell division
I'll
point,
still be here when you get
then
What time are you? I might just stay tonight and go to work.
now we
Yeah,
can
we'll see.
hit the finish line, just like we, well, I guess we could say the start and stops. In the
I'll
very
text you if I
now
head
we
out.
can divide.
Okay. I love
And
you.
hopefully the cell is dividing in the best form of itself. Great help for the cell in that critical case. And that way those divisions could be healthy. If we find ourselves with disrepair or maybe a mutation that can't be fixed, the cell has like an auto-destruct button that's built into it. And usually that's a chemical message to the cell that says, I am going to undergo cell death because I should not be dividing in a non-healthy form. I should not be dividing while mutated or in disrepair. So it kind of kills itself off. And it's for the greater good of the rest of the cells too. Its cell death is, again, more so genetically programmed. And when it goes through this programmed self-destruction or programmed cell-death, it's a process known as apoptosis. We'll discuss this further, I believe, with next week's topic. It's a form of cell-death. So it's kind of neat that the cell's looking out for itself and, of course, the rest of the body and its cells. When we get to the red writing says start. I know it's a little sloppy, but the red writing says start. I'll give you a more detailed diagram as we get to the cell cycle and future topics, but this is just more like a precursor of just kind of getting to know what the cell is doing and why we have so many trillions of cells in the body. Because ultimately they divide, they have to divide. Cells have like a built-in lifespan in the chromosomes of the cell. So every time a cell divides, a little bit of what's in the chromosome and what makes up the chromosome, which is something called the telomere. I'll draw it out for you. Here's like the chromosome itself. Now the telomeres are kind of like the terminal ends of these chromosomes. They're these little caps. Think of it almost like a pencil eraser, number 2 pencil. So every time a cell divides, these caps start to erase off a bit. I erased a little bit too much there, but the caps eventually go away. The eraser comes to an end, and so to speak. So when those telomeres are completely gone, then the cell programs itself to die as well. So that's another kind of moment when the cell will say, hey, it's time for me to go. I've done everything I should have done in my lifespan, and it has divided so much that it really is time for it to go. But this is how we get trillions and trillions of cells. All cells except red blood cells contain the entire genome. So kind of think about that. It's a lot of cells with a lot of compressed information in them. And if we're looking to other topics, I guess, of discussion, I'm going to jump over to stem cells. They're a little bit less specialized, but do provide a good reserve of cells. And we're starting to see stem cells a little bit more open